Hello everyone, and welcome back to the channel. Have you ever stood in your kitchen, grabbing your favorite pot to cook a delicious meal, and wondered, how is this actually made? It seems so simple, a basic tool we use every day. But behind that familiar pot lies a fascinating journey of transformation, a story of raw power and delicate precision. Today, we're pulling back the curtain and taking you deep into the heart of the factory to uncover the incredible process of how raw metal is turned into the essential kitchenware we live without. From a simple, flat disc of metal to the polished, durable pot that sits on your stovetop, it's a journey filled with heat, pressure, and incredible engineering. So, stick around, because you're about to see your kitchen pots in a whole new light. It all begins with massive rolls, or large sheets of high-quality metal. For most of the pots you see in stores, we're talking about stainless steel or aluminum. These metals are chosen for their excellent heat conductivity, durability, and resistance to rust and corrosion. The first step is to cut this raw material into perfect circles. Huge machines, with immense power, act like giant cookie cutters, stamping out perfectly uniform metal discs. These discs are the blank canvases, the very foundation of what will become our pots. At this stage, they are flat, plain, and don't look like much, but they hold all the potential. Each disc is carefully inspected to ensure it has no imperfections, because a flawless start is key to a flawless finish. It's amazing to think that the sturdy pot you use to boil pasta starts its life as just one of these simple, flat circles. Now for the magic, or rather, the science of deep drawing. This is where the flat disc begins to take on its familiar pot shape. The metal disc is placed into a massive hydraulic press. Then, with incredible force, a punch pushes the disc down into a die, a mold in the shape of the pot. The metal stretches and flows, rising up around the punch to form the walls of the pot. It's a delicate balance. The pressure has to be just right. Too little, and the pot won't form correctly. Too much, and the metal could tear or wrinkle. This process might be repeated several times, with different dies, to gradually stretch the metal to the desired depth and shape, whether it's a deep stock pot or a shallow saucepan. This is the moment of creation, where a 2D circle dramatically transforms into a 3D vessel. Once the pot has its basic shape, it's still a bit rough around the edges. The top rim is uneven from the drawing process, so it needs a trim. The pots are placed on a spinning lathe, and a sharp cutting tool slices off the excess material, creating a perfectly smooth and level rim. This step is crucial not just for looks, but also for function. It ensures that a lid will fit snugly on top. After trimming, some pots get their rims curled or rolled. This isn't just for decoration. It reinforces the edge, making it stronger and less likely to bend or dent from daily use. It's these small details that contribute to the overall quality and longevity of a good pot. Next, it's time to prepare the pot for its most important feature, the base. For many high-quality pots, especially stainless steel ones, the base isn't just a single layer. To improve heat distribution and prevent hot spots that can burn your food, manufacturers add a multi-layered base. This usually involves sandwiching a core of aluminum or copper metals, known for their superior heat conductivity, between two layers of stainless steel. This process is called impact bonding. The base of the pot is heated to an extremely high temperature, and then the layers of metal are fused together under thousands of tons of pressure. It's like a high-tech blacksmithing process, permanently bonding the metals into a single, solid unit. This composite base is the secret behind a pot that heats up quickly and evenly, giving you better control over your cooking. It's a feature you can't see, but you can definitely feel the difference when you cook. What's a pot without handles? Now it's time to attach them. Depending on the design and quality, handles are attached in one of two ways: riveting or welding. Riveting is the classic method. Holes are drilled into the side of the pot, and the handles are fastened securely with strong metal rivets. This creates an incredibly durable bond that can withstand the weight of a full pot. You can always spot a riveted handle by the small, smooth metal heads on the inside of the pot. Welding, on the other hand, offers a sleeker look. High-energy spot welding is used to fuse the handle directly onto the pot's exterior. This leaves the interior surface completely smooth, which some people prefer for easier cleaning. Both methods are designed to ensure the handles are firmly attached and can safely support the pot for years to come. With the main construction complete, the pot is starting to look like the finished product, but it's still dull and covered in marks from the manufacturing process. It's time to make it shine. This is where the polishing stage comes in. The pot goes through a series of automated and manual polishing steps. It's treated with progressively finer abrasive compounds. First, to smooth out any surface imperfections, and then to bring out that beautiful mirror-like shine or a sophisticated brushed satin finish. This is a labor-intensive process that requires a great deal of skill, especially for getting into the curves and corners. This polishing doesn't just make the pot look good. It also makes the surface less porous, more resistant to food sticking, and easier to clean. It's the finishing touch that elevates the pot from a piece of industrial hardware to a beautiful kitchen tool. For many of us, a non-stick surface is a must-have. If a pot is destined to be non-stick, it goes through an additional, highly specialized process. First, the interior of the pot is sandblasted or chemically etched. This roughens the surface just enough to create tiny peaks and valleys for the non-stick coating to grip onto. Then, the coating, most commonly a form of PTFE, is applied in several thin layers using a specialized spray gun. After each layer is applied, the pot is sent through a high-temperature oven. This curing process bakes the coating on, bonding it permanently to the metal. Applying multiple layers is key to creating a durable, long-lasting non-stick surface that can stand up to daily cooking and cleaning. It's a precise science to ensure an even and effective coating. We're almost at the finish line. Before any pot can be packaged and sent to a store near you, it undergoes a rigorous quality control inspection. Every single pot is carefully examined. Inspectors check for any visual defects like scratches, dents, or imperfections in the polish or non-stick coating. They check that the handles are secure and that the base is perfectly flat, ensuring it will sit evenly on a stovetop. They also make sure the lid fits perfectly. This final check is the gatekeeper of quality. Only the pots that meet the highest standards are approved. Any that fail are either sent back for rework or recycled. This commitment to quality is what separates a great brand from the rest and ensures that the product you bring into your home is safe, reliable, and built to last. Finally, the perfect pots are ready to meet their new owners. Each pot, often along with its lid and an instruction booklet, is carefully packaged. The packaging is designed not only to look attractive on the shelf, but more importantly, to protect the pot from any scratches or damage during shipping. From the factory, these boxers are shipped to distribution centers, and then on to retail stores or directly to your doorstep if you ordered online. And that completes the journey. From a simple disc of raw metal, through intense heat, immense pressure, and a series of detailed finishing touches, the humble kitchen pot is born. So the next time you're whipping up a storm in the kitchen, take a moment to appreciate the incredible journey your trusty pot has been on. It's a true testament to modern manufacturing and engineering. Thank you so much for joining me on this fascinating tour behind the scenes. I hope you found it as interesting as I did. If you enjoyed this video and learned something new, please give it a big thumbs up. And don't forget to subscribe to the channel and hit that notification bell so you won't miss our next adventure. We love exploring how the world around us works. Thanks again for watching, and we'll see you in the next video.